Activity series. We were talking about redox equations and reactions. If we take a strip of magnesium metal and put it in a solution of copper ions, a chemical reaction will occur. The magnesium loses electrons. Oxidation is loss of electrons. So the magnesium gets oxidized, the copper ions become reduced, and copper deposits on the magnesium strip. Okay, cool. Well, what if we do the opposite? What if we put a copper strip in a solution of magnesium ions? Nothing happens. Why? Well, this is an energetically favorable reaction only in the forward direction. It doesn't want to go in the reverse direction. And what we use to help us to predict this is called an activity series. An activity series lists metals in order of decreasing tendency to lose electrons. So the ones at the top of the list are most likely to lose their electrons. They're most likely to react. So my chemistry land analogy for this is think back to high school and imagine the girls keeping a list of the hot guys, right? And they list the hot guys at the top and the nerdy guys at the bottom. So the guy at the top is most likely to get a date, or if he goes stag to a party, he's more likely to steal the anion, the girl, from somebody else, right? So the metals at the top have the greatest tendency to lose electrons. They're the most reactive, and the metals at the bottom have the lowest tendency. They are the least reactive. So here is one activity series. So lithium, very, very active. Lithium is more active than any of these. So if lithium meets, say, magnesium as an ion with a girl, a reaction is going to occur. And lithium's going to take the girl. Lithium's going to lose the electrons and become part of this couple. So these half reactions are most likely to occur in the forward direction. The ones at the bottom are more likely to occur in the reverse direction. If gold, as an ion, goes to a party with a girl, he'll give up that girl very easily to anybody above. He's a wimp. Okay? So you can predict what will spontaneously happen by looking at this list. If the half reaction on the list is above the other one, it'll occur. It's hard to explain it that way. Let's look at an example, but not quite yet. Gold is very low on the activity series. Here's a gold key among all these other keys. One of the reasons that gold is so popular for jewelry, besides that it's so beautiful, is that it doesn't tarnish, right? It doesn't react with much of anything. It will react with mercury, though. If you have gold jewelry, you don't want to be around mercury. It'll completely ruin it. But gold doesn't react with a lot of stuff. Iron rusts, even silver tarnishes very easily, but gold doesn't. And so it makes an excellent metal for jewelry. So what we need to be able to do is look at something like this and determine if this reaction is spontaneous in the direction that is written. So we're going to look for the metal. Here we have zinc going to zinc ions. This one, nickel 2+ going to nickel, is the opposite. Let's go back to that full activity series, right? So here's nickel. So nickel ion going to nickel, that's a backwards reaction. What was the other metal? I forgot already. Zinc, thank you. And here's zinc. So zinc going to zinc ion, that's the forward direction. So we're looking at the metal, and if the metal is above the ion, nickel. I know you guys are fried. It's the end of the semester. My brain is fried too. I just can't remember anything. So here's the partial list. Okay, so what we're going to do is we're going to look for the metal, and here's the ion. If the metal is above the ion, he's going to take the girl. So in this list, zinc is higher than nickel. I can't even find them in this stupid list. This reminds me, there was an old Saturday Night Live skit, and I don't know why I keep telling this because most of you are too young to remember it, but it was Ricardo Montalban, and he was talking about ¿Quién es muy más macho? Okay, so, listing the guys, who's more macho, Ricardo Montalban or, I forget the other guy. Anyway, sorry. Just scratch that.
That's it?
That's it. It was just so funny, but you had to have seen it. ¿Quién es muy más macho? So if we imagine this is actually occurring as a single displacement reaction, and so maybe we have nickel, what happened there? Nickel sulfide, and then we'd end up with zinc sulfide plus nickel by itself. Here's nickel as the ion. Nickel's got a date. Zinc is coming in by himself. But zinc is more active than nickel. And so that girl's going to say, oh, he's more macho. I'm going to go with him. So she leaves with him and nickel's out on his own. That's how you use the activity series. You're looking at which of these guys is higher on the list. If that one is the metal, the reaction will be spontaneous because zinc is more active than nickel. So this reaction is spontaneous. Let's look at this one. Here we have zinc and calcium. So here's calcium, and here's zinc. Calcium is more active. In this equation, calcium is the ion. That means he's already got the girl. Is he going to give it up to zinc? Zinc can't steal the girl. So this reaction will not occur spontaneously. It can be forced to occur, but it will not happen on its own. Any questions? Stunned silence. You don't have to memorize the activity series. Uh-huh.
So, is it only, because I knew oh wait, never mind. No, it doesn't make sense.
You okay?
No.
No? Doesn't make sense? Okay. So, who's more macho? Zinc or calcium? Calcium is. In order to be with the girl, it has to be an ion. Okay? Here's calcium as the ion. Calcium already has the anion. He's already in the compound, in the relationship. And zinc's coming in, making a bid for the girl. But calcium is more reactive, more macho. Zinc can't steal the girl from him. Here we've got zinc and nickel. Zinc is more active than nickel. Nickel's got the girl, but zinc is more macho, and so when he comes in, he can take the girl and become the ion.
But it looks like the same.
What's changing between this and this? Well, here zinc is an atom, and here zinc's an ion. It's lost electrons. Here nickel is an ion, and here it's an atom. It's gained electrons. So there's oxidation and reduction occurring.
But calcium is still an atom.
Down here, yes.
So it doesn't matter unless he's higher on the rank, right?
Here we have calcium as an atom, but this reaction actually isn't going to happen. This is what would happen if it went forward, but it doesn't. It stays here. It's not spontaneous. The only way you can get, one way you can get this to go is to apply a large voltage through this, and you can get the reaction to occur, but you have to put energy into it. It's not going to happen on its own. It's like you have to bribe the girl to go with zinc or something like that. I don't know.
Because calcium already has the girl.
Calcium has the girl, and he's more active. He's more reactive. He's more macho. He's higher on the list. He's not going to give it up. Okay? because this is a list of calcium going to calcium ion, zinc going to zinc ion. Let's think about it this way. Didn't mean to do that. There we go. So if we look at these half reactions, I left my stylus upstairs. I'm writing with my finger. Yes. On an iPad, it's nicer because you don't have to bite it and write in blood. I said people, I need a pencil. Well, just bite your finger and write in blood. I'm fine. There's not much writing on this one. So these are the two half reactions that we're looking at. This is a forward for this, and this one's backwards. Okay? The forward reaction has to be higher. So zinc is lower than calcium. And so zinc going to zinc ion is not going to happen if calcium has to go the other way. It's just not working, is it?
Does it have to remain aqueous to have that anion?
The ion will be aqueous.
So the other one will be a solid?
Well, the metal is a solid, yeah. Because metals aren't soluble in water. Right, because it became an ion. And it depends if the anion that's paired there is insoluble, then it could become a solid. But we don't know what the anion is. It doesn't matter. Well, let's look at it this way. Uh-huh.
On the top one, the ion zinc wants to take the ion.
Zinc wants the girl. So the nickel 2+ is part of an ionic compound that's dissolved in water. And I'm saying, well, let's say it's sulfur. So here we have nickel sulfide. And so when we learned about single replacement reactions, the zinc is going to come in and take the place of nickel. So he's going to be with the girl, with the anion. And then nickel will be out by himself. And so if zinc is more desirable, more active, then sulfur will go with him instead.
Okay. And then on the bottom one, though.
On the bottom one, the calcium is more active.
So it's not going to lose the ion?
No. So if we look at these two, zinc going to zinc ion, calcium going to calcium ion, and we look on the list, we see calcium wins, right? So calcium gets to be the ion, zinc doesn't.
So the second half of that reaction doesn't even happen, right?
This part doesn't happen, no.
Yeah.
So-
it stays in the beginning.
Yeah, it doesn't go.
Yeah.
It will not happen spontaneously. If you put zinc ion and calcium together, those will react, but zinc and calcium ion will not react. You can run this backwards. Zinc ion and calcium together will react, but zinc and calcium ion will not react. I'm sorry. So look at the two metals, zinc and calcium. Forget ions or anything. Find out the one that's higher in the list. It's calcium. Calcium gets to be reduced. It gets to lose its electrons. Its reaction happens. So which side has the calcium ion? The left side. It's going to stay on this side. Up here, zinc and nickel. Well, who wins? Here's zinc and nickel. Zinc wins. Find the side with the zinc ion. So here's zinc ion. This side is where it's going to go. Does that help? So this one actually is going to go that way. Okay? Because calcium wins. And up here, zinc wins. This reaction goes forward. This reaction is actually going to go backwards. So the forward is not spontaneous. Any better? A little better? A little better. Pardon me?
So like if it goes this way, then it's spontaneous. If it only goes on the left side, then it's not spontaneous.
Yeah, if the reaction is written pointing to the right, like this one, and the zinc is winning, then it's spontaneous. If it's written as this is written, going in the forward direction, it is not spontaneous because the reverse reaction is spontaneous. I think I have another example here. No, well, this will kind of get into another example. Some acids, well, actually, most metals are dissolved by acid, but not all. And we can predict which ones will dissolve in acid by looking at hydrogen ion, which is the component of acid that reacts, and looking on the activity series. Going back to that activity series real quick, here we have hydrogen gas going to hydrogen ions. So the metals that are above hydrogen will be dissolved by acid, and the ones below will not. So metals above hydrogen on the activity series dissolve in acids. Those that are below don't. One exception is nitric acid. Some of the things like copper will dissolve in nitric acid, but that's going through a different process. You don't need to worry about that, but I want to tell it to you just in case you say, yeah, but, yeah, I know. It's one of those exceptions. So here we have what happens when we put zinc and acid together. We can predict whether this is going to happen by finding zinc and hydrogen in the activity series. Here's hydrogen, here's zinc. Zinc is higher. Zinc wins, zinc gets to be the ion. And so we look at this and we find, well, which side has zinc as the ion? It's this side. This is going to go forward. Okay? So, does silver dissolve in hydrobromic acid? We don't need to even know that it's hydrobromic acid, just acid. Where is silver? Well, silver's down here, and hydrogen's up here. Hydrogen wins. If we were going to write this reaction, we'd have silver plus hydrogen ion going to silver ion plus hydrogen. We're going to have to stick some 2's in there. So we see that hydrogen wins. So which side has the hydrogen ion? It's this side. It's going to stay on this side. It's not going to go forward. It's not going to dissolve in acid. Silver doesn't dissolve in acid. Things like iron does dissolve in acid. That's the end of chapter 16.